Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Hopefully you're having an awesome day today and ready to learn something. We are in TryHackMe once again. This is the SOC Level 1 learning path, Endpoint Security Monitoring module. This is the Core Windows Processes room. Explore the core processes within a Windows operating system and understand what normal behavior is. This foundational knowledge will help you identify malicious processes running on an endpoint. Before we get into it, be sure to like, comment, and subscribe if you are enjoying the content. Now, without further ado, let's go ahead and dive into it. Task 1 Introduction. In this room, we'll explore the core processes within a Windows operating system. This room aims to help you know and understand what normal behavior within a Windows operating system is. This foundational knowledge will help you identify malicious processes running on an endpoint. And that's absolutely true. If you're going to be on the blue team side of things, you need to know what's normal and what's abnormal so that you can investigate and then get rid of the bad guys. The Windows operating system is the most used in the world, whether people like it or not, and the majority of its users don't fully understand its inner workings. Users are simply content that it works. Like anything complex, such as cars, it starts and you can drive from point A to B. Now, regarding computers, if they can surf the web, read, answer emails, shop, listen, blah, blah, blah. It took a long time for users to grasp the need for enterprise programs fully. Only when one of their essential everyday computer functions is disrupted is when antivirus matters. Antivirus was never enough, or antivirus was enough over 5 to 7 years ago. Rough estimate. Time changes, everything, malware and attacks have evolved, and antivirus is no longer enough. Antivirus has struggled to keep up, and solely based on how it is designed to catch evil. Today, antivirus is just one solution within the layered defensive approach. New security tools such as EDR, which is Endpoint Detection Response, have been created because antiviruses cannot catch every malicious binary and process running on the endpoint. But guess what? Even with these new tools, it still is not 100% effective. Nothing is 100% effective, which is why you have layered security or defense in depth. Attackers can still bypass the defenses running on endpoint. This is where we come in. Whether you're a security analyst, a SOC analyst, detection engineer, or threat hunter, if one of the tools alerts us of a suspicious binary or process, we must investigate and decide on a course of action. Knowing the expected behavior of the system, we have to defend a Windows system. In this case, we can infer if the binary or process is benign or evil. That's absolutely true, as I just explained earlier. Okay, if you want RDP into it, here's the credentials and information on how to do that. We're going to continue to task number 2. We're going to talk about the Task Manager, which is a GUI-based Windows utility that allows users to see what is running on the Windows system. It also provides information on resource usage, such as how much each process utilizes CPU and memory. When a program is not responding, Task Manager is used to end or kill the process. We'll give you a brief overview if you're unfamiliar with Task Manager. To open Task Manager, right-click on the taskbar. When the new window appears, select Task Manager as shown below. Hopefully, you all know what Task Manager is and have used it at some point. I'm sure you have if you ever ran across a system or application that did not work properly, right? So you go down to this taskbar here and you right-click and you click this Task Manager, and then you go to whatever program like Chrome or something, and you click on it and you click End Task because it's using up all your resources, right? Chrome is a resource hog in that case. But anyway, so this is Task Manager. Click on this more details so you can see various different processes running on the machine here. You got different tabs here, performance. You can see performance with CPU, memory, Ethernet, right, which is your network information here. You got users who's logged in, right? So you see administrator, and they're running all kinds of stuff here, right? And you can see details for other things here. Kind of breaks it down a little bit more, right? And then you have services. So you can see what services are running, stopped, things of that nature. You can right-click inside of here, play around with these services, do all kinds of things. All right, so let's jump back over here and see what they're talking about. If you don't have any explicitly open apps, you should see the same message below, which we just saw. And we click more details to bring out more information. Okay, we already did this. Click on processes. We're in there right now. If you're running Task Manager on your Windows machine, you might see additional tabs. As we do see, oh, okay. I'm assuming if you're running this on your own, like personal Windows machine, not inside the VM here, then you might see something else there. All right. And then they just note the tabs here. So you have apps, background, processes, another category that's not visible. Above images, Windows, processes. The columns are very minimal. The columns, name, status, CPU, and memory are the only ones visible. To view more columns, right-click on right-click on any column header to get to the more options. All right, so let's do this here, and then here's our options here, and let's see if they want us to type or to click on any of these. I guess not, but if you wanted to, just go and click on type. I usually don't mess around with this stuff here, but if you wanted to, because you can do something like that. So we'll just leave it like this for now. The new view looks better. Let's briefly go over the column name, of course, and let me see here. Okay, so they did type, publisher, PID, and some other things. So let's just follow along here. Type, publisher, PID, and I think command line was one of them too. They did everything, it looks like. Okay, it then explains what they are. So type, each process falls into one of three categories: apps, background processes, or Windows process. So if you're looking at type, we can see that here, right? And of course, click on it if you want to arrange it by type, right? It says publisher, think of this column as the name of the author of the program file. So we can see publisher, Microsoft Corporation, and you'll see other ones in here like Chrome. We'll probably say Google Corporation, Firefox, will say like Mozilla or something like that. PID, which is the process ID or process identifier, right, for long terms. Windows assigns a unique process identifier each time a program starts. If the same program has multiple running processes, each will have its unique process identifier, or PID for short. And you can see that here, so you can arrange that as like so. So take notes of these things. Command line, the full command line used to launch the process. So we're going to move over here. We see it here. And if you want to make this bigger, just click in between here. You see these two arrows and double click it, and then it'll expand it for you automatically. So you can see everything. So let's click on this. And we see all kinds of things running. CPU, the amount of CPU processing power the program uses. Okay, so if we slide over again, we can see that here. And memory, the amount of physical working memory utilized by the process. So the amount of RAM it's going to be using up inside of here, right? Task Manager is a utility you should be comfortable using, whether you're troubleshooting or performing analysis on the endpoint. Let's move to the Details tab. Also, you can hit, like, I believe it's Control-Alt-Delete, and then you can pull up the Task Manager that way as well. So let's follow along here. Details. This tab, or this view, provides some core process that will be discussed in this room. Sort the PID column so that the PIDs are in ascending order. So let's go ahead and do that here. All right, looks good to go. Add some additional columns to see more information about these processes. Good columns to add are image path name and command line. So let's do that. Just follow along here. Select columns. Okay, and then want image path. Let's see if we can find it in here. Image path name and command line right next to each other. Awesome. Okay, so here we are. Expand it a little bit. Okay, I'm gonna kind of shrink this a little bit. There we go. Okay, these two columns can quickly alert an analyst on any outliers within a given process. In the below image, PID 384 is paired with a process name svchost.exe, a Windows process, but if the image path name or command line is not what expect it to be, then you can confirm or perform a deeper analysis on the process. So we should see something like this. And that's true. A lot of times attackers will try to pretend to be service host, and maybe they'll inject into that process to try to look legitimate or try to remain longer on your system. So here's one of them right here, and we can see that here. And let me show on the right, process ID. They wanted us to go to, let's see here, 384. Okay, I assume it's 384 for theirs, but ours is a 532, looks like. Anyway, of course, you can add as many columns as you wish, but adding the columns that would be pertinent to your current task is recommended. That's why you can clear up, basically saying don't clutter up too much. Add the needed columns that you need in order to do the investigation. Task Manager is a powerful built-in Windows utility, but lacks certain important information when analyzing processes, such as parent process information. It is another key column when identifying outliers back to servicehost.exe. If the parent process for PID 384 is not services.exe, this will warrant further analysis. To further prove our point, where is services.exe? And theirs is at 632. Okay. And let's see if we can find errors real quick. And let's see. Okay, there it is, service.exe 764. Okay. Based on the above image, the PID for service.exe is 632, but wait, one of these servers svc.host processes has a PID of 384. How did services or servicehost.exe start before service.exe? Well, it didn't. Task Manager doesn't show a parent-child process view. That is where other tools or utilities such as Process Hacker and Process Explorer come to the rescue. And those are good tools as well to learn about and to practice hands-on. All right, so if you look at Process Hacker, you would see something like this, get more details and such, so you can see the breakdown here. Okay, and then here's another one from Process Explorer. Neat. Moving forward, we'll use Process Hacker and Process Explorer instead of Task Manager to obtain information about each Windows process. As always, it's encouraged that you inspect and familiarize yourself with all information available within Task Manager. It's a built-in utility that is available in every Windows system. You might find yourself in a situation where you can't bring your tools to fight and rely only on native tools to the system. Aside from Task Manager, it would be best if you also familiarize yourself with the command line equivalent of obtaining information about the running processes using task list, get process or PS, PowerShell, WMIC. You'll maybe have to use multiple different tools as they just said here. And let's see here. And I wish they would have it easier to find things in here. That little find or magnifying glass. Let's try search here. Okay. Oops. Let's try this again. Search. And nothing's typing out here. Okay. Let's see if I can get to it this way. There we go. This is just trying to find PowerShell just to show you how this looks real quick. Keen is running kind of slow. All right, so let's try task list first. See how it looks like in the command line. So that's one of them. And let's clear the screen. And then let's do get process. And it's lagging a little bit here. This is annoying. Okay, let's try this again. Okay, so there you go. There's another way of doing it. And then I'm going to try one more here. This is running slow. PS. There we go. All right, cool. So let's move on to task number 3. We're talking about system here. The first Windows process on the list is system. It was mentioned in a previous section that a PID for any given process is assigned at random, but that is not the case for a system process. The PID for system is always 4. What does this process do exactly? The official definition from Windows Internals 6th edition, the system process ID 4 is the home for a special kind of thread that runs only in kernel mode, a kernel mode system thread. System threads have all the attributes and context of regular user mode threads, but are different in that they run only in kernel mode, executing code loaded in the system space, whether that is in NTOS kernel, I guess, .exe, or in any other loaded device driver. In addition, system threads don't have a user process address space and hence must allocate any dynamic storage from operating system memory heaps, such as a paged or non-paged pool. Okay, it's pretty interesting. Let me check one thing real quick. Make sure I didn't miss anything up here. Okay, so let's go ahead and see what we're talking about here. What is user mode, kernel mode? Visit the following link to understand each of these. So click this link and go familiarize yourself with those two modes. Now, what is normal behavior for this process? Let's use Process Explorer to view the properties of the system. Okay, and let's see here. Process Explorer right here. Let's just do this one here. Bring up this interface. So we should see something like this when we start looking at system, right? All right, so wow, let's take a look here. So there's system, Okay, so we double click in here, and then we can see similar information. So we see that system, then 4, and then let's look at the same results as they do here. Okay, the information is slightly different if we view the system properties using Process Hacker. So let's go ahead and compare it to Process Hacker real quick. Let me get out of this. Okay, so technically this is correct. You may notice that Process Hacker confirms this is legitimate verified Windows Mark stuff. What is unusual behavior for this process? And let's see here. Okay, so we have it open here. Double click on it, and we have similar information as they got here, right? Okay, so let's continue on. What is unusual behavior for this process? A parent process, aside from system idle process 0, multiple instances of system, you should only see one instance, a different PID or process ID. Remember that the PID will always be 4, or PID 4, not running in session 0. Awesome. So remember these right here so you can identify what's normal versus what's abnormal, okay? Make sure to take note of that. What PID should system always be? And it says 4, right? PID should be 4 right there. So there's the answer for that one. Task number 4, system, and then smss.exe. So let's see what they're talking about here. The next process is smss.exe, Session Manager Subsystem. This process, also known as Windows Session Manager, is responsible for creating new sessions. It is the first user mode process started by the kernel. This process starts the kernel and user modes of the Windows subsystem. You can read more about it, or more about the NT architecture here. This subsystem includes win32.sys, kernel mode, winsrv.dll user mode, and csrss.exe user mode. smss.exe starts with csrss.exe Windows subsystem, and wininit.exe in session 0, and isolated Windows session for the operating system, and csrss.exe and winlogon.exe for session 1, which is the user session. The first child instance creates child processes or instances and new sessions done by smss.exe, copying itself into the new session and self-terminating. You can read more about the process here, so check that out. And here's pictures of what they're talking about here. So let's take a closer look here. Oh, that's really small. Um, so let's take a look at it inside of here, Process Hacker. Okay, and I'm going to minimize this. Looks like there may be in Process Explorer. Okay, so let's just take a look here. All right, they're looking at token. Let me go back to Process Hacker. Maybe I just missed it real quick. Yes. Okay, so click on token here. All right. And it says session 1, csrss.exe, and when log on. Okay. Good to know there. And then they're looking at some other stuff inside of here. So basically just play around with this and see what information you can find by clicking on these various different processes that they're referring to here. So is it another one? It looks like it talks about when log on stuff. There's one down here. Here's one log on. Okay, cool. It says any other subsystem listed in the required value of this here, session manager subsystems, is also launched. Okay, that's good to know. SMSS is also responsible for creating environmental variables, virtual memory paging files, and starts winlogon.exe, Windows Logon Manager. What is normal? And this is normal here. Okay. Image path has it listed out here. Parent process system, number of instances, 1 master instance, and child instance per session. The child instance exits after creating the session. User count, local system. Okay. And then start time within seconds of boot time for the master instance. What is unusual? A different parent process other than system 4. The image path is different from C Windows System 32. All right. And more than one running processes, child self-terminate and exit after each new session. The running user is not the system user. Unexpected registry entries for subsystem. Okay, that's good to know there for SMS, smss.exe. So I'm just trying to find it real quick over here. All right, let's see here. All right, now that's a lot easier to find. Okay. And they are in the general tab for things. Okay. So if you want to reference that thing, or I clicked on the wrong one. There we go. Okay. Now we're in the right one. So if you want to reference what they're looking at here in the screenshot, you can do it this way here. And it says, aside from csrss.exe, what process does smss.exe spawn in session 1? And let's see here. Session ID, column, and process hacker might help you, but it's also covered in the task in detail. Okay. So we need to add session ID, column, and process hacker. And let's see if we can do that here. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Okay, so if you wanted to search for session IDs inside of Process Hacker, you can add another column here called session ID. So if you just, I believe it was in, if you just right click on one of these columns here, it'll give you choose columns, so you can just add various columns that you need. Okay, so if you were to look for that, then you can do it that way. You can use Control F and you can search for it here. So smss.exe, pull up various different things referencing that, right? But anyway, so for this question, you have to go back up to the top where it talks about smss.exe and csrss.exe. You can see that it explains what this is. It says that in an isolated Windows session for the operating system and csrss.exe and winlogon.exe for session 1. So that should be our answer down here, session 1. So it's referencing, and then winlogon.exe should be our answer for that one. Okay, so session 1, winlogon.exe. All right, so task number 5 here. It says, as mentioned in the previous section, csrss.exe is the user mode side of the Windows subsystem. This process is always running and is critical to system operation. If this process is terminated by chance, it will result in system failure. This process is responsible for the Win32 console window and process thread creation and deletion for each instance, which are these DLLs here, and loaded along with others. The process is responsible for making Windows API available to other processes, mapping drive letters, etc., etc., etc. You can read more about it here. A note, recall that csrss.exe and winlogon.exe are called from smss.exe at startup for session 1, which we just saw that again. So what is normal? And here's another picture of what's normal here. Session 0, PID 392, and they're looking at csrss.exe for that. Okay, so that's normal. And then here's another one here where they're looking at it at PID 512. All right, looks good there. I'm just gonna make this a little bit bigger so you can look at it. Okay, just notice what is shown for the parent process for these two processes. Remember, these processes are spawned by smss.exe, which self-terminates itself. And we can see that here for this information down here. It says image path, okay, and then it says created by an instance of smss.exe, and it says user account, local system, start time within seconds, of boot time for the first 2 instances for session 0 and 1. Start times for additional instances occur as new sessions are created, although only sessions 0 and 1 are often created. So what is unusual? An actual parent process, smss.exe, calls this process and self-terminates. Image file path other than C Windows 32. So when it says parent here, it says non-existent process, right? Because it says it self-terminates there. All right. So if there's something other than that, then you might want to look into that. Subtle misspellings to hide rogue processes masquerading as csrss.exe in plain sight. The user is not the system user. Okay. Take notes of everything we just saw there. So what is the process which had PID 384 and PID 488? So 488 and 384, well, we know that's going to be smss.exe because it says that created by an instance of smss.exe, right? So that's what it's referencing here. And that's true because it says what's unusual. So if it says something other than that, then you need to look into that, okay, according to what we just learned here. So remember that. Task number 6, wininit.exe, and it stands for the Windows initialization process. wininit.exe is responsible for launching services.exe, Service Control Manager, lsass.exe, Local Security Authority, and lsass.exe within session 0. It is another critical process or Windows process that runs in the background along with its child processes. You see something like this here, and let's just look at our VM here and see if we can find that. So wininit.exe. So let me just arrange this real quick. Okay, there we go right there. All right, and it says note that lsass.exe is a process associated with credential guard and key guard. You will only see these processes if credential guard is enabled. Interesting. What is normal? So this is normal here. Okay, so if it has something other than this, then you need to look into it, right? And it explains it even further down here. Parent process created by an instance of smss.exe, right? Which we know that it self-terminates, which is why it says non-existent process. Number of instances, 1, user count, local system, start time within seconds of boot time. Okay, so what is unusual? An actual parent process, smss.exe, calls this process and self-terminates, as I just said. Image file path other than this here, system32. Subtle misspellings to hide rogue processes in plain sight. Multiple running instances and not running as system. So we're starting to see a pattern here for these items here of unusual activity, right? So let's continue on here. Which process might you not see running if credential guard is not enabled? Well, if we scroll back up here, what references that? It says you will only see this process if credential guard is enabled. So if this is disabled, then you will not see this lsass.exe process, okay? So remember that. Task number 7, wininit.exe, services.exe. The next process is Service Control Manager SCM or services.exe. Its primary responsibility is to handle system services, loading services, interacting with services, and starting or ending services. It maintains a database that can be queried using a built-in utility called sc.exe. So if we want to look at this, let's just plug this into our virtual machine real quick. We should get something like this in return. Okay, and I guess I closed out my PowerShell session, so let's just get back in it real quick. PowerShell. All right. You get all kinds of information there for it. All right. And you can get examples down here of syntax to use. So let's flip back over. Whoops. And it says information regarding services is stored in the registry, which is control set services. Okay. And if you want to go to the registry using regeditor to find it, you can do it this way here. Okay. This process also loads device drivers marked as auto start into memory. When a user logs into a machine successfully, this process is responsible for setting the value of the last known good control set, last known good configuration, which is HKLM system select last known good to start or to that of the current control set. So we can see that here in this picture. Like I said, if you go into registry editor, you should see something like this. Okay. And since this process is the parent to several other key processes, service host.exe, spool, service.exe, lms, mpeng.exe, host.exe, to name a few, you can read more about this process here. So check that out if you're interested. You can see this here that has a lot of services running or processes listed here for that. Okay. And I'm not sure if we would see something similar on this VM here, but let's see. Let's flip over to Process Explorer. All right, there we go. All right, so we can see various different items here listed. All right, cool. I wish it would tell you which tool to use here. It would make it a lot easier to navigate to such a tool to look at this information, but let's continue on. So what is normal? Here's another image of what's normal inside of here. Okay, parent process here, wininit.exe. So there you go. If it's something other than this that's listed here, that's something you need to investigate further. Services.exe, session 0. And here's more information here that breaks it down. Image path, here's services.exe, wininit.exe. Number of instances 1, user account, local system, start time within seconds of boot time. So what is unusual activity here for this? A parent process other than wininit.exe, image file other than C Windows System 32, subtle misspellings to hide rogue processes in plain sight, running multiple instances, and not running as system. Awesome. Question time. How many instances of service.exe should be running on a Windows system? Well, we already know there should be just one instance running, right? It says multiple instances. If it's running multiple instances, then that's something that's unusual, okay? And then it says up here, number of instances 1. So that's going to be our answer down here for service.exe, right? Okay, next one is task number 8, wininit.exe, service.exe, and svchost.exe. So let's see what they're cooking with here. The service host process for Windows services, or ServiceHost.exe, is responsible for hosting and managing Windows services. And this is what it looks like here if we were to look at it in one of those programs. The services running in this process are embedded or implemented as DLLs. DLL to implement is stored in the registry for the service under parameters, subkey service DLL. The full path is here. Okay. You see it's going into parameters. And then this is what it looks like in regedit right here. Okay. To view this information within Process Hacker, right-click on the ServiceHost.exe process. In this case, it'll be PID 748. So if we want to look at it in Process Hacker here, and make sure on the right one, that's right. So we're looking at ServiceHost.exe. So let me flip back over here. There's a bunch of them running, a lot of them. Okay, so we'll just look at one of them, I guess. And what did they go to here? They went to services. So let's just follow along. Right-click, and then let's see. Okay, I guess it's this. Services, and then they went to decom launch, go to service. Okay, it just looked a little bit different on my screen. Right click the service and select properties to look at the DLL. And did I click the wrong one? Let's try this again. Oops. Let's open this back up. Okay, so let's try this. Right click on this, and then we need to go to services, right? Go to service. Okay. All right, it's giving me different responsive. Anyway, let's just look for it here. And all right, I'm assuming that. Okay, so it looks like they just selected a random one, and then it just went over to whatever service it was referencing. Okay, so we're in the right track here. Look at the service DLL. All right, so let's just go back here to reference. I'm gonna open this back up again, and let's just click on one here. We'll go to services, and then we'll go to. So this one's a little bit different. We'll just select a random one, I guess. Let's see this one here. Go to service. Okay, you can see the DLL here. All right, cool. From the above screenshot, the binary path is listed. Also notice how it is structured. There's a key identifier in the binary path, and the identifier is -k. This is how a legitimate service host.exe process is called. The -k parameter is for grouping similar services to share the same process. This concept was based on the OS design and implemented to reduce resource consumption. Starting from Windows 10 version 1703, services grouped into host processes change. On machines running more than 3.5 gigabytes of memory, each service will run its own process. You can read more about the process here. Back to the key parameter -k from the binary path. In the above screen, the -k is DCOM launch. Other services are running with the same binary path in the virtual machine attached to this room, right? Which we already saw that. I mean, there's a bunch of them running. Each will have a different value for the service DLL. Let's take LSM as an example and inspect the value of the service DLL. So they're going ahead and look at this one here, and we already looked at one on our VM here, okay? Just a random one we chose there. Since svchost.exe will always have multiple running processes on any Windows system, this process has been a target for malicious use, as I explained earlier. Adversaries create malware to masquerade as this process and try to hide amongst the legitimate service-host.exe processes. They can name the malware service-host.exe or misspell it slightly, such as svchost.exe. By doing so, the intention is to go under the radar. Another tactic is to install/call a malicious service or DLL using that. Extra reading this hexacorn blog. So check that out if you want to read more into that. What is normal? Once again, here's a screenshot of what's normal here. So if it doesn't look like this, then it's probably suspicious, okay? And you need to look into that. And there's more information down here that breaks it down. Okay, image path, parent process service.exe, number of instances many, which we saw on the VM there. User count says varies. It can be system, network service, local service, depending on the service host.exe instance. In Windows 10, some instances run as the logged in user. Start time typically within seconds of boot time. Other instances of svchost.exe can be started after boot. Okay, so what is unusual here? A parent process other than services.exe, image file other than going to the system32, subtle misspellings, and then also the absence of the -k parameter. That was very important. They had outlined that earlier that we just read about. So question time, what single letter parameter should always be visible in the command line or binary path? Well, we know that's going to be the k parameter, okay, which they referenced multiple times inside this task here. Task number 9, lsass.exe. So let's see what they're talking about here. That says, per Wikipedia, Local Security Authority Subsystem Service, LSASS is a process in Microsoft Windows operating systems that is responsible for enforcing the security policy on the system. It verifies users logging onto a Windows computer or server, handles password changes, and creates access tokens. It also writes to the Windows security log. It's a very important process. It creates security tokens for SAM, which is the Security Account Manager, AD, which is Active Directory, and net logon. It uses authentication packages specified here in HKLM system control or current control set control and LSA. Okay, you might actually come across this if you ever use a tool called Mimikatz, by the way, and they just reference it down here, by the way. All right, let's take a look. lsass.exe is another process adversaries target. Common tools such as Mimikatz are used to dump credentials, or adversaries mimic the process to hide in plain sight. Again, they do this by either naming their malware by this process name or simply misspelling the malware slightly. Next, reading how LSASS is maliciously used and additional features that Microsoft has put into place to prevent these attacks. I highly recommend looking into how this is exploited by attackers and then looking into this Mimikatz tool because you may come across this in the real world. Okay, attackers love to use Mimikatz on things. What is normal? So it's in the screenshot of what normal is. So once again, if it doesn't look like this, then it's abnormal and you should look into it further. So it just breaks it down even more here. So you got LSASS, image path, parent process, wininit.exe, number of instance 1, local count, local user, start time within seconds of boot time. And what's unusual here, parent process other than wininit.exe, image file is different than this, subtle misspellings, multiple instances running, and they're not running as system. So if it doesn't fit this criteria as normal, then you should look into it further, okay? And it highlights what activity could be abnormal on it. Okay, question time. What is the parent process of lsass.exe or lsass? And if you scroll back up, you can see that the parent process is going to be wininit.exe, okay? It also mentions it here, a parent process other than wininit.exe. So there's our answer there. Task number 10, winlogon.exe. So let's see what they're talking about here. The Windows logon or winlogon.exe is responsible for handling the secure attention sequence SAS. It is the Alt-Control-Delete combination users press to enter their username and password. This process is also responsible for loading the user profile. It loads the user's user.dat into HKCU, and user init.exe loads the user's shell. Reading more about this process here, so check that out if you're interested. And we're looking at it again in registry editor. Okay, so we got winlog on here. Here's the path to it. You got shell right here, explore.exe, and then user int down here. Okay. And let's see here. It is also responsible for locking the screen and running the user's screensaver, among other functions. You can read more about this process here. Remember from earlier sections, smss.exe launched this process along with a copy of csrss.exe within session 1. All right, and this is what it looks like here. What is normal? Once again, they're highlighting what's normal here. So if it's different from this, if it deviates from this, you need to look into it because it's suspicious activity. Okay, and then there's another one here where it says session is 1 and users into authority system for this particular one. All right, so here's another breakdown of it. Image path is this here, parent process created by an instance of smss.exe that exits. So analyst tools usually do not provide the parent process name. All right, you'll see that here, it's non-existent process. Number of instances, 1 or more, user count, local system, and start time within seconds of boot time. For the first instance, for session 1, additional instances occur as new sessions are created, typically through remote desktop or RDP or fast user switching logons. What is unusual? It says an actual parent process, smss.exe, calls this process and self-terminates, so very important to remember that. And here's the path to it if it's different from this. Subtle misspellings, and then you got not running S system, then shell value in the registry other than explorer.exe, which we saw there inside of the registry editor. So we can see that here, shell, and then you have explorer.exe. Okay. What is the non-existent parent process for winlog.exe? Well, we know that's going to be smss.exe because it self-terminates, right? As it states there. Task number 11, explore.exe. The last process we'll look at is Windows Explorer or explorer.exe. This process gives the user access to their folders and files. It also provides functionality for other features such as the Start menu and Task bar. As mentioned previously, the winlogon process runs userinit.exe, which launches the value in HKLM software, Microsoft Windows NT, current version winlogon shell, userinit.exe, Essex or Essex exits spawning explorer.exe. Because of this, the parent process is non-existent. So something else to take note of here. There will be many child processes for explorer.exe, of course. There's going to be a ton for this one. So if we want to take a look at this in the VM, let's just get out of all this here. And let's see here. I'm going to try to arrange these. Okay, so we got Explorer. There we go. And if we minimize this, you can see that there's a bunch running under there. And this is in Process Explorer. So if we want to look at it in this Task Manager and Process Hacker, let's just open this back up again. Okay. Let's see. Let me go ahead and arrange this real quick. And I'm just going to search for it up here. Explorer. That actually we can see other processes running underneath there. So that's good to know there. And let's see, what is normal? Once again, highlighted items here is what's normal. So if it's not in this, deviates from this, suspicious, and you should look into it further. And here's a breakdown of it down here. Image path, explorer.exe, parent process created by userinit.exe and exits. Okay, so you're going to see once again, once it exits, it's going to say non-existent process. Number of instances, 1 or more per interactively logged in user. User count logged in users. Start time, first instance when the first interactive user logon session begins. And what's unusual, an actual parent process, userinit.exe calls the process and exits. Image path other than C Windows, okay, other than C Windows, running as an unknown user, subtle misspellings, and then outbound TCP IP connection. So they're looking at explorer.exe properties in this here. And so if there's actual connections in here, that would be suspicious according to what we just read about here, right? So let's see here. And they went to TCP IP. It doesn't say what tool they used to look at this, which is kind of annoying. But let's see here. Explorer.exe. There we go. So I'm looking at it in Process Explorer, by the way. So yeah, there's nothing in there. So there's nothing suspicious in this area from what we just learned. Note the above image is the Explorer.exe properties view from Process Explorer. Okay, I wish it had said that before it had that screenshot on there. But anyway, what is the non-existent process for Explorer.exe? Well, we know that's going to be user init.exe because remember it says it terminates, right? It says user init.exe calls this process and exits. So there we go there. So it's going to say non-existent process for that parent process there. All right, if it doesn't say that, then it's suspicious and you should look into it further. Task number 12, we're going to wrap it up here. Reading a lot of things to take in here. Understanding how the Windows operating system functions as a defender is vital. The Windows processes discussed in this room are core processes, and understanding how they usually operate can aid a defender in identifying unusual activity on the endpoint. With the introduction of Windows 10, new processes have been added to the list of core processes to know and understand normal behavior. Earlier, it was mentioned that if credential guard is enabled on the endpoint, an additional process will be running, which will be a child process to wininit.exe, and that process is lsass.exe. This process works with lsass.exe to enhance password protection on the endpoint, right? And we know that this is commonly targeted by attackers and such, right? As we learned about in this particular room. Other processes with Windows 10 are runtime broker.exe and task host w.exe, formerly taskhost.exe, and taskhost.exe. Please research these processes and any other processes you might be curious about to understand their purpose and their function or normal functionality. The information for this room is derived from multiple sources here. They have them listed out here to check out more information. SANS is a great resource, by the way, of looking up cybersecurity related items. Other links are provided throughout the room. Reading them at your own leisure to further your foundation and understanding of the core Windows processes is encouraged. Checking out the links in this room and get familiar with these processes because it only makes you a better blue teamer. It makes you a better cyber defender out there. I guarantee these attackers are looking into these processes and they're going to be exploiting items. And you need to know what to look for on Windows machines if you expect to be a good incident responder, a good defender, things of that nature. Okay. Anyway, we covered a lot of information in this room. Holy moly. So I recommend that not only do you play around with this virtual machine and look around using Process Hacker and Process Explorer, you don't even need to use virtual machine, by the way. You can fire up your own machine and check out these processes with these tools here that you'll probably use in the real world, by the way. But anyway, if you enjoyed the video, you want to support the channel, be sure to like, comment, subscribe, hit that notification bell, and I will see you in the next video. Thank you, and see you later.